Hello and welcome to my presentation. In this presentation, I will talk about systems development frameworks. Um, I will I will talk about two of them, Waterfall and Agile. If you look at part two of my presentation, I talked about project management frameworks. Okay, let's start with today's presentation. Okay, in this presentation, we'll talk about project management methodologies, system development, waterfall, and agile. In the next presentation, that is part 5, I will talk about Scrum, Kanban, and Spiral methods. But for this time, for this presentation, I'm going to talk about waterfall and agile methods. So let us consider first the waterfall methods. Now, the waterfall is best suited for projects with well-defined and stable requirements. What it really means is that because this is a linear sequential system development, if we really change your requirements, it requires a change of design. But the waterfall is not suited for a frequently changing requirement. This has to really be sort of stable. We know exactly what we're really looking for, and then we can go ahead and design the systems and implement. So there are certain steps that we need to follow if we are really looking to use waterfall. These system development methodologies are really fitted for the behavior of the systems you want to develop. If the systems you're developing are well known, the products or the systems that you're really going to be in the deliverables are well articulated, then they're going to change, then most probably waterfall is applicable for those kinds of projects. So when you're really doing sort of waterfall, the first step is you just require to really collect that requirement. There are a number of ways to gather. We're going to have a look at that one. So second one is once we know exactly what the requirements are, we're going to go to the certain design of the systems. In here, the design is just creating a detailed specification in there, and then develop that. The implementation is the process of writing the code that is you are implementing your design. Once your design is governed or guided by the requirement that really gathered from stakeholders. And then the next one is implementation, the process of writing code and building the systems. And then you're going to test whether that system is working as specified in the requirement. It really gives you that is the product that you really want to do. That is what you specify in terms of the requirements. It gives you on those ones. So the next stage is, yes, you develop the systems now, you tested it, you deploy it. So this is installing and deploying the systems. So what happens is, does this really systems work with other systems which are existing in there? One of the questions you really need to ask. And then one is sort of the deployment, then the process of making ongoing changes and improvements before really does it really work properly? Does it really require certain improvement? And then to make sure this is the needs of the organization, the needs of the requirements which we really gathered have been satisfied fully. So those are the key elements in terms of the design stages. So when you're really starting gathering the requirements, one thing that's really important is to identify the stakeholders, what is really their need, what's their expectation, and defining the functional and non-functional requirements for the systems that you really are creating. So the requirement, this is a goal or the aim is to create a clear, comprehensive understanding what the system should do. This is what it's really expected to do. This is what you're going to really provide. So these are some of the common techniques of gathering requirements are stakeholders. You're going to go interviews, do surveys. You might really even create a prototype for users to have a look at it, to taste it. This is what the flavor, what it looks like, what it really feels like in terms of the um, deliverables. You might really use cases. This is, for example, you might really create a systems whereby one element of the systems will be demonstrated, what we call it the use cases. Okay, so you might really even use a requirement workshop, bring stakeholders together to collaborate and requirement, ensure that all perspectives are considered. So those are the key elements. Some of these workshops really will bring out in terms of the requirement for different stakeholders most probably will be different. So how do you accommodate that requirements for different stakeholders? So you bring all the stakeholders, do a workshop to really find out exactly what are the compromising elements for different stakeholders, what they're really looking for. So this is, once requirement gathering is completed, you have a well documented requirement, so that will really guide the design process. So designing defining the architecture, what looks like the architecture, what looks like, what kinds of components we require to do, what kinds of modules we're gonna really develop in terms of that component, and data for an information system. This is almost looking at the product breakdown, which we have really looked at in part 3 of my presentation. These are the things that will really consist of the whole system, from the top to the bottom to the elements of the system. So you are creating a sort of a detailed specification and diagram that is how the system should be built. This is from, you can see that one, this is from top down design. This is a sort of important element in terms of the design of the whole system. So the architect designs is defining the overall structure, and the component really, so defining the individual component of the systems, and that will be refining in terms of the structure relationship of the data you're going to really use, how many tables you really require, what kinds of elements, what are the relationships really required in there, and then how that is really the interface is designed in terms of between the system and its user. But bear in mind that you have to really think about security design as well. Once it is really designed, this is, you implement the process of those design, those architecture, those components. Okay, so use those modules, you really bring them. So how do you do that? When you start writing your code, writing the code to implement functionality, integration, bringing all those components together to work together and provide what the systems really requires, and then you test it, performing testing to verify the system is a requirement. You might really need to do debugging, fixing, testings. So improving as well, refactoring to improve the design of the structure and code to make it more maintainable or efficient. To do these are the implementation stages. And then you really do a sort of a complete testing of the whole system, testing individual components or modules. So you just test level by level. You might really test module, component, structural levels in total. So integration testing, the components to ensure that they work together, those elements really comes together to work as a system as a whole, and then the whole system will be tested. So you really look at then user acceptance testing. This is, the user will come on board to test how the system works, and then how it really feels to operate it. And then performance testing, these are most probably the specification you really have also. At what speed you think your database really responds to a request. Those most probably sort of performance testing, you test that. And security testing is the systems really secure, measure to ensure that it's protected against so on. So these are the elements that you need to do in terms of testing of the developed systems, from the module to component, and the functionality of the interfunctionality of those components to create what we call the system, and the whole system will be tested from the user perspective, the performance perspective. These are the sort of the performance normally tells you so the quality of the system, how is the quality of your development or the systems really responds in terms of performance, and the security elements as well. Once you really completed the testing, now you really goes to the installation of the system, installing software and components. So you go to the configuration, and the configuration in terms of software to work together environment, including setting up database, network, and other infrastructure. So integrating the system with other systems and techniques, such as you might really develop APIs, data source, and security measures. And then you move the data, migrate to the system, moving data from legacy systems to the database. So the continuously monitoring performance of the system, the production environment, to identify and resolve any issues, and then outcome of the development of this one. Okay, once this is really implemented, you might really need to do bug fixing, defects or bugs in the system, feature updates, adding new features or improving existing functionality, and then you really optimize performances, security updates, and documentation is really an important element in terms of maintenance, monitoring the performance of the system in the production environment to identify and resolve any issues. One thing which is not really mentioned in here is what happens if the systems really fall apart, it doesn't really work. Okay, we have to really have a sort of to roll back to the older systems if the whole system doesn't really work. So we have to have really those kinds of arrangements, plans, the well established plans are in place in case something goes wrong. Now let's look at agile methodology. This is a software development methodology. Its nature is iterative in terms of the development. You bring one element of it that it can be tested and looked at. This is a high level of collaboration between stakeholders and adaptability to changes. What it means is the agile system development methodology is more suited for systems that the specification changes continuously, almost continuously, where stakeholders, users come on board as not only sort of part of users, but as designers of the system, whereby the specification continuously changes depending on what they're really looking at. So it really prioritizes customer satisfaction, collaboration, and flexibility over strict planning and coherence to a fixed plan. So this is not a sort of, is contrary to a waterfall system, whereby you really changes your priorities, your specification, your requirements. So the foundation for agile is that it is iterative development. It develops bare systems to use for to be tested, used by stakeholders, and then based on that it really improve continuously through each iterative development, development where users are involved highly, and this is a sort of a collaboration between stakeholders, customers, developers, and other team members. And this is one of the key elements is flexibility. Agile encourages adaptability to changing requirements, so allowing stakeholders to change their minds about what they want. So once they really see that what the working systems looks like, they might really say, hey, we can have really additional features in here, or the button I wanted it to work here. So the advantage of these systems is the users brings the business rules and then how things really work in that business, which is really interpreted in terms of the system's development structure. This is how it should really work in terms of it. So agile, because of its flexibility, is really involves users. It implies that there is a continuous improvement in terms of what can be really improved. So promotes a culture of continuous improvement where teams are encouraged to reflect on their work, identify ways to improve their processes. So these are the key elements of in terms of the agile system development. And then we have to really prioritization. Agile prioritize the most important features and requirements. We're gonna have a look at how we go about prioritizing what should really be done first and last. Customer involvement is hugely really important elements of as agile. Uh, Without the customers, you cannot actually really do a sort of agile system to development. So you have to bring customers or users as your co-designers, basically. So the this is the sort of iterative development software approach to that involves repeating cycle of development testing. So it is what you're gonna do is first you're gonna build a minimum variable product MVP MVP and then iteratively refine and improve it over time. So you really create a sort of a mere minimum bare viable product, what it looks like, how it really functions. So early feedback by delivering MVP early, and then you give based on that feedback. That iterative process continues. It is flexible. This is continuously improves the quality of the product by repeating cycles, how it's really improved, and reduces risk. Iterative development reduces the risk of delivering products that doesn't meet the needs of the stakeholders, because the stakeholders are part of the development systems, as they may allows teams to test and validate their assumptions. So those are the key elements of this. It reduces the risk that failure of product development has reduced because stakeholders are really involved. A faster delivery, this it takes really much shorter time span to deliver the product you're really looking at. So this is the key elements are collaboration is a key aspect of software development. It refers to the process of working together as a team to achieve a common goal. So that creates what we call is a better understanding by working closely with the stakeholders. So you really understand what the requirement is, how the business rules and the things that what concerns about the business is reflected and understood by systems designers to include it in their systems design. This creates a sort of improved communication, collaboration. This really gets in terms of provides a faster delivery and provide higher quality because it really improves the whole system. And the other one is a sort of in terms of increased flexibility because it allows collaboration and the changes of in the specification. Okay. So flexibility is a key characteristic of software development. It's responding to change quickly. That implies improved quality, and it really produces sort of what we call it a faster delivery, reduced risks, and really provide what we call is a better customer satisfaction. Okay. Continuous improvement is a key principle in software development. The advantage is increased efficiency, high level of better customer satisfaction, because really customers are really involved in the design and testing and validation of the product. That gives us improved quality. This is really increased team morale in terms of when you're really working together as a team. There is a better communication, a better team morale. Then there is a level of increased competitiveness continuously to provide the systems. So which one should we really prioritize in terms of what should really do first? There are a number of methods in terms of prioritization. The normally used is a Moscow method. This method really prioritizes tasks in terms of these are the must have, should have, could have, or won't have. These are the things that really prioritize in terms of what should the system must have, what should have, or could have. Those are the kinds of divided into four groups, and then you really tackle in terms of the must-haves. The other prioritization method is what we call is urgency and importance matrix. All the tasks are really divided in terms of the matrix. This matrix really divide the tasks either urgent or that important. The importance and the urgency, and then there are element focuses in here what we really need to do. The things which are urgent doesn't necessarily really produces the goal or the outcome what you really want is in terms of the total systems. Okay, but the tasks which are really important means those important tasks produces the outcome you require. So this is one of the things. The Eisenhower matrix, this is a matrix made by product tasks based on their urgency and importance, like the urgency importance matrix. But the Eisenhower matrix include level of difficulty and personal preferences, what should really be in terms of it. And here, important tasks normally enables to achieve goals. That is what you really need to really aware of it. Okay, tasks that are really urgent doesn't necessarily mean it is progressing towards your outcomes or goals you are really looking for. The other one, the prioritization method, is what we call it value-based prioritization. This is the method prioritizing tasks based on the value they deliver to the customer. So which one is really valuable to the customer? Which systems should we really develop first? So this is mostly looking from the customer point of view. And the next one is the phase one is lean prioritization, is a method for prioritizing tasks based on customers' values and team's ability to deliver it. So this is looking at both sides of the things. One, hi, the customers, what are the customer values? Most probably the customers' values, most probably task A, B, and C, most probably in the order which you really put the customer's value. But can we really provide what are our capacity for the team to whether to produce in this order? Do we have the skills and the knowledge set to provide that? So these are in terms of the ability of the teams that really produces the system and the value of the customers. So in terms of prioritization, it's important software development helps team to focus on most important work, reduces the risk of delivering product that doesn't meet the customer need. It's also a key aspect of project management as it helps to ensure resources are used effectively and the project stays on track. So these are really important in terms of task prioritization techniques. So the customer agile and customer's involvement. Customer involvement refers to the active participation and engagement of the customer in software development. There are several benefits. It really provides a better requirement. Remember what I said earlier. These customers are really considered as co-designers. They design the system with the developers in such a way that their inputs is so important for including bettering up, making better requirement or improve user experience in terms of that involvement, that the customers might not really know the level of the ability of the system, what it can produce. So understanding that from the designer, they really put their ideas, how the business rules and regulations are implemented in the systems. So that really provide better customer satisfaction because you're really providing based on that with a better technology, a better customer satisfaction. This really gives us what we call it improved communication. Communications enables us to really engage and bring us the better requirements, better designs, and that really brings us as well that the product is to be developed at a faster speed, so faster time to market. That is the process, the involvement of the customers brings the systems or the products at a faster rate to the market. Thanks very much for your attention. I will stop recording now.